They spent over $20 billion building the world's longest sea bridge, and here is exactly where every dollar went. Domestic steel pricing alone saved billions compared to any Western project. Full breakdown coming.
Local concrete at massive scale saved 30% versus any Western equivalent, and watch the full breakdown.
Prefab steel and concrete made this bridge faster and cheaper than any Western project, and full story linked.
Watch the full $20 billion cost breakdown of China's longest sea bridge right now. They spent over $20 billion. Here is exactly how steel and concrete turned into the world's longest sea bridge.
420,000 tons of steel and vast concrete made this possible at unmatched scale.
Built to last 120 years against typhoons and earthquakes through domestic efficiency.
Completed in just 9 years for nearly $20 billion through domestic steel and concrete chains.
Domestic supply chains and prefab made it cheaper and faster than Western projects.
Prefab and domestic materials kept the budget at scale, pricing, saving billions.
Prefab and domestic materials kept the budget at scale pricing, saving billions.
Now see exactly where the $20 billion went in steel and concrete.
But how did $20 billion of steel and concrete create this engineering marvel?
Domestic steel pricing kept material costs far below Western imports.
By utilizing this advanced steel alloy, we've designed a bridge that is both stronger and more sustainable.
Slabs rolled into precision plates, then fabricated into giant box girders.
These girders alone took 25% of budget at scale pricing.
Limestone and aggregates quarried locally, burned into cement for durable marine concrete. Cement mixed with admixtures in high-volume plants near Pearl River Delta. Both steel and concrete barged or trucked directly to site at low domestic prices.
Massive stockpiles of steel beams and concrete mixing showed material scale impact.
Steel and concrete arrived, ready for seabed preparation and foundations.
Seabed preparation and pile driving set the foundation for the entire bridge.
Prefabrication of hybrid segments cut erection time and labor costs dramatically.
Giant segments transported by barge to assembly points.
Lifting and connecting prefabricated girders using balanced cantilever method.
Balanced cantilever cut months off schedule and saved labor costs. Cable installation and tensioning for the cable-stayed bridge sections. Tensioning ensured the bridge withstands typhoons and earthquakes. Sinking and joining immersed tunnel tube sections, steel reinforced concrete. Steel reinforced concrete tubes joined to form the underwater link.
Artificial island construction with concrete and fill plus deck paving.
Deck paving and finishing completed the road surface for traffic. Quality control testing and scale-driven cost optimization throughout.
Scale and prefab made this project cheaper and faster than any Western equivalent.
Concrete volume at local prices
saved 30% versus Western equivalents.
Rigorous testing throughout, guaranteed long-term structural integrity.
Automated steel plate cutting, welding, and assembly of massive box girders.
Welding created strong, precise box girders for the bridge.
Assembly in automated yards produced girders ready for site.
High-volume concrete batching, mixing, and pouring for caissons, piers, and islands.
Concrete at local prices form the massive foundations and islands.
Pouring created strong, durable piers and caissons for the sea bridge.
Curing and form removal produced perfect piers for the bridge.
Foundations completed, set the stage for girder installation. Prefabrication and transport of hybrid segments by barge. Lifting hybrid segments into position on prepared piers. Lifting and connecting prefabricated steel box girders onto piers. Balanced cantilever method connected girders efficiently.
Girders connected formed the main spans of the sea bridge.
Cable installation for the cable-stayed bridge sections. Tensioning completed the cable-stayed sections. Sinking immersed tunnel tube sections into position. Joining created the continuous immersed tunnel.
Artificial island construction with concrete and fill.
Deck paving and finishing completed the usable bridge surface.
Quality control and testing ensured the bridge met all standards.
Scale Steel and Concrete delivered this project cheaper and faster than West.
Every step optimized for maximum efficiency and value. Smooth traffic now flows across the completed mega sea bridge.
Scale Steel and Concrete. That's how China built it cheaper and faster.
This is the power of scale and domestic efficiency. This is how the 20 billion created the longest sea crossing.
The cost breakdown shows the power of efficient engineering. This is the full money breakdown of the mega sea bridge.
The 20 billion cost breakdown is complete.
Scale Steel and Concrete, the secret to China's mega projects.
Steel, concrete, and vision built this engineering wonder. The $20 billion story is now yours to share.
Thank you for exploring the mega sea bridge cost.
This production by MassaBuild is created for educational and illustrative purposes using advanced AI technologies. Every frame in this video has been transformed through a multi-stage editing process. From GIF conceptualization to video generation, human creativity leads every step. MassaBuild channel is dedicated to original AI craftsmanship and follows all 2026 YouTube monetization rules.